back. Here we
Wait,
are.
I didn't get you in that.
Wow, you got
Back.
I
Here we are.
zoomed up super. Okay, there you go. Now you're
Never
in.
mind. Never mind.
I'm sorry, I
Gotta
killed
be
your
here
dreams.
to get this. All right. So we took the velocity, initial, final, acceleration, time, and distance in the y direction, and we filled in all the parameters for this problem. So if you were able to get all of those, not one by one this time, if you were able to get all of those, you may cross out G1. All right. The equation when we have this kind of situation is the Voter again. So take the Voter equation. This time we're in the y direction. All right. Emily, can you fill in the values in the equation?
Sure.
Go ahead.
X is what you're solving for, so
Right.
that just says X. VO, so it'd be 13 times 1.8 plus 1/2 negative 9.8 times 1.8 squared.
All right, lots of numbers. No solving algebraically, just crunching. So that means we plug these numbers in and we crunch it all out, and the drum roll begins, because now we'll know if it's a goal or not. Because the goal is 2.4 meters high. At that point, where is the ball? You're about to tell me, Zach.
what's that? You got 39.27
Meters?
high.
Really?
You're at 7.5.
Never mind.
What did you do?
13 times 1.8.
I got 7.5 too.
Plus
Did
1/2.
you do
Did you square the
negative?
last one?
Did you do negative 9.8?
Yeah, why is it negative instead of positive? Because like I know like some places it's
The only time that we drop it is in the range equation.
okay.
And that's because when we developed the range equation, we had the negative sign disappeared in our
Okay.
work. But
So it's
every other
negative
time, it's
every
gonna
other-
be
okay.
there. Pardon?
He didn't make
Well,
it.
how many?
7.5.
Oh,
He was so close. Just over.
7.5.
Wait,
Alright.
what?
5 meters away.
7.5 from 2.4 is pretty
I
high.
think it's 100 didn't come.
He zung it up there.
He
Alright,
was close.
so it was too high. How
That's a
much
short
too
goal.
high? How much too high was he?
That's a short goal.
Calculate that for me, Emily Keene. How much too high? Everyone got 7.5 meters?
5.1.
How much?
I got 6.83.
5.1. Alright, so when you subtract
6.83 meters.
2.4, and this kind of disappeared in my picture, this is all my work. 2.4
Yeah,
from
5.1 difference.
7.5.
We got 7.5 as the answer. Do we have
5.1 meters too high, that's quite a bit. So,
what's their bingo number?
no, he wasn't close.
He got his frowny face with his ear.
We need to get some
Alright.
O's.
If you got 7.5 meters, when you put the numbers and crunch them out, you can cross out B1.
Sure, I guess we can
Oh no.
Alright.
You're very close to bingo.
I have one more.
No, don't tell me what it is, I won't
No,
know.
you. I said you're
Yeah,
close.
me. Oh.
In 2 spots. If you
Gotta
just
get
get some
something
O's.
Okay.
If Miss Powell gets bingo, then we all get -1.
Alright, this is
Don't
the
get plus one.
This is the creme de brulee, if you like creme brulee. This is the creme de la creme. This is the hardest problem, except maybe that 14 stepper, although you were so used to doing 12, I won't call that more difficult. But this is the hardest problem, I believe, on the test, this kind of problem. Because you had to go over to X to get the time and use it in Y. Sometimes we have to go over to Y and get the time to do it in X. So this is an example. So that's why I wanted to start the review with the worst one. Are there any questions on any steps along the way? All right. We'll keep practicing those until you've got them cold.
Yeah.
All right. We'll start another one tomorrow, so you should be able to do it without me going through it step by step. I'll just release you to do the whole thing. But for now, let's switch gears. Write down the range equation. This is still on your review sheet. What happens to R, the range, when V sub O is tripled? From this point on, the author of this curriculum loves these kind of problems. So you can easily get these if you take my training today and use it. He'll ask these questions on every test. And you'll notice in the SAT and other kinds of math-related evaluations, they like it too. So what you have to do is look at that equation and stick a 3 in it somewhere, I'll give you that much, and tell me what the net effect is. So the question, here's the range equation, write it down, and write down the question, what happens to R when V sub O is tripled? Are you writing it?
How specific of an answer are you looking for? Like, is it just supposed to be like
Like,
increases,
is it-
decreases, or is it
I
like?
had to figure out if it was a goal.
We did. We even told how much he missed it by.
I don't know, how do we figure it out?
Oh, how do we figure it out?
Yeah,
Well,
'cause
we know
got
the goal
seven
is,
distance,
the goal is
7.5, right?
yeah, we got, the goal was 2.4 meters high, and his shot at this point was 7.5 meters high.
Oh,
So he missed it by 5.1 meters.
wow.
Yeah, he shot it to the moon. All right, mathematicians, here's what we do. What happens to R when V sub O is tripled? You gotta go in and put a 3 next to the V sub O. That 3 is hugging the V sub O. And before it is even squared. So you have to change the V sub O before it's squared. But then the equation squares it. So whatever you do to this side, you have to do to this side. So should I put a 3 over here and say, well, if I tripled the V sub O on this side, I have to triple it on that side? It wasn't really a tripling, it was 3 squared. So I have to adjust with not a 3 on this side, but a 9. So the answer is, the way I would like you to say it is, the range increased by a factor of 9. So this is training. So I won't give you a bingo on this one. So let me give you a different one. So write that down as part of your training. What happens to range when V sub O is tripled? The range increases by a factor of 9. All right, so let's change the question. Do you have that down? Answer as well? All right, I'm going to change the question. This one's for a bingo, now that you're all trained. What happens to R when V sub O is doubled? So this will be for a bingo. What happens to R when V sub O is doubled? The answer is, the range is multiplied, or is increased by a factor of 4. All right, because when you put the 2 in here, is then squared, because the equation squares it, and we get a 4 on this side. So the answer is, the range increases by a factor of 4. All right. If you did that, you can cross out I-5.
Killing me.
Killing me, you're really.
Part C is related to Part B. This time you will not be able to tell me by what factor so much. No, you may be able to, but I'm not asking you to. Here's the equation. If G, oops, we need a G. Alright, if G is increased to 10.44 meters per second squared, like you're on Jupiter or something, what happens to the range? All I want to know, does it go up or does it go down? So, see if you can answer that question. Observe where G is in the equation and imagine it going up. So when it goes up, what's going to happen to R? So think that through. So you're going to answer as either R is going to increase or decrease. How do you think we're doing for time?
I started at like 19, so it's been like 9 minutes, I think.
About 9? Okay, hopefully we can keep going a little bit.
Because class ends at 35, so we should be like.
Well, we might not be able to get it all. Alright, we'll find a stopping point just to make sure. It's much easier to upload smaller videos. Alright, so the answer is, if G is increased, if this number gets bigger, and because it's in the denominator, remember, you're taking something that's staying the same and you're dividing it now by a bigger number, then this should decrease. If you put R, decrease, you put R decreases, you can do O1.
No.
I know,
Alright, tell me what happens if we go to, what's that? Is Venus smaller than the Earth?
Yeah.
Alright, Venus is smaller. Okay, what happens if we go to Venus and we shoot our projectile? That's the 5 minute. Yeah, besides that. In addition to dying, say we go to Venus, and at Venus the planet is smaller, so a smaller planet is going to have a G that's what? Less or more? This isn't for bingo, we're just discussing it.
Less.
It is less. The smaller the planet, the less pull it has. So if we go to Venus, what will happen to our range compared to Earth? If this number goes
bigger.
down,
Maybe
this
bigger.
number goes up. What if we go to the moon?
Maybe smaller.
We'd have a really big range.
It'd be really big. If you toss a baseball on the moon, it'll just surprise you how far it will go.
Really?
Right, because G goes way
So
down.
until like 300 yards.
So when the
football.
denominator goes down, the value of the whole fraction goes way up. Alright.
Something's wrong with that visual.
Is that it?
Binoculars.
You're not gonna see how big. Throw it.
In space.
Alright. You can show them this. Show them this. Just the first problem. Just the first problem. Or actually the first page.
Zoom out.
First
Now
page.
it's not working space.
Okay, here's the first problem.
Binoculars work in space.
Yeah, exactly. Emily Davis.
But why would you bring binoculars to space?
The Hubble, the Hubble is a big binocular.
There's the second
Brian,
one.
I wonder if aliens can see
You
me.
might want to pause it.
Like,
And
if
here's
telescope
the
watchers,
third
wow, this
one.
Earthling.
That UFO thing, have you seen that video?
Yeah,
There it
there
is. Well,
Alright, here's what I want you to do for
Okay, there
our
you go.
review tomorrow. We're going to go through these problems tomorrow. The first page, though, is a little slower than the rest. The rest is like theory, which we can zip through. But let's do for right now, I want you to start problems number 1. Start problem number 1. That's the one, I said 14 steps, but it could be 16 steps, remember? This is the long one that we started this mod with. Remember, they give you a velocity vector, you have to check the units, and then you have to change velocity to displacement, and then you have to do the 12-step adding vectors. So, on this one, let's, for homework, so we don't have to take so much time tomorrow, let us do 1, 2, 3, let's do the, how many are on here, 15? Let's do 1 through 6 for homework, and starting that now. And then when we come in, we can go through them quickly and review the rest for the test on Thursday. So write that at the top, numbers 1 through 6 for the, for homework. Bring those in so that we can go quickly through them, and you'll
The
see.
last thing we did was that quiz or a test? This is the same thing again.
I'm sorry.
Was the last thing we did was that a quiz?
Where? When?
Like the last test, I don't know. Last test we did. 2 weeks ago. I don't know if it's a test.
It was a test.
Test, okay. So I'm like, this is the same stuff.
Yeah, this is same except